Hi everyone, my name is Jarul Prajapat and today we'll be doing the first chapter of grade 10 CBSE Science, that is chemical reactions and equations. In this video, I'll be doing an introduction to this chapter, and the topics I'll be covering in this video are what is a chemical reaction, how to identify a chemical reaction, and lastly, I'll be touching upon chemical equations. The remaining topics will be covered in further videos. Now, the first thing that we need to understand in this chapter is what a chemical reaction is. Now, a chemical reaction isn't something that only happens in the lab with fusing chemicals and explosives. It's actually something that takes place in our day-to-day lives. When we think of burning of a candle, or rusting of iron, or even cooking of food, all of these are chemical reactions which I'm sure you've seen before. So, what exactly is a chemical reaction? A chemical reaction is a process in which new substances with new properties are formed. Essentially, in a chemical reaction, two or more substances react, they undergo chemical changes to form new products that chemically differ from the old substances. Now, this is a very important point over here. The new products or new substances formed have to be chemically different from the old substances, and only then can we say that a chemical reaction has occurred. To explain this further, let me use the help of an example. The burning of magnesium. As you can see in this image, magnesium burns with a dazzling white light in the air. Magnesium reacts with oxygen in the air to form a completely new product known as magnesium oxide, which occurs in the form of a white powder. In this chemical reaction, magnesium and oxygen react together. They undergo chemical changes to form a new product, magnesium oxide. And hence, in this chemical reaction, magnesium and oxygen are known as the reactants, as they react together to produce a new substance. And the final new substance that comes out of a chemical reaction, that is magnesium oxide in this case, is known as the product. Every chemical reaction has a product and a reactant. I've been talking about chemical changes that occur during the chemical reaction. And by these chemical changes, I mean two things. One, the rearrangement of atoms, and two, the breaking of old bonds and the formation of new ones. These points will be better explained using this image. Over here, we can see that we have one gray atom and two red atoms combined together in a molecule. These two react together to form a new substance in which the gray atom is in the center and the red atoms are on either side. To form this new substance, these atoms rearrange themselves in such a way, and the old bond between the red atoms breaks, and a new bond between the gray and red atoms form. Now that we've understood what a chemical reaction is, the next thing we need to know is how to identify whether a chemical reaction has taken place or not. To do this, we need to understand that every chemical reaction has a few observable characteristics or features, and if we can identify these features or characteristics, we can conclude that a chemical reaction has taken place. The first observable characteristic is a change in color. I'm going to be explaining this using this example. In this image, we have a beaker of copper sulfate which is blue in color. When iron is added to the copper sulfate and iron react with each other to form a new product, iron sulfate, and the color of iron sulfate is green. Hence, the solution in the beaker changes from blue to green, and since there's a color change, we can conclude that a chemical reaction has happened. The second feature is the evolution of a gas. When many substances react, they produce a gas which escapes or evolves in the form of bubbles. Over here, we can see that dilute sulfuric acid and zinc granules react together to produce hydrogen gas, which is escaping the solution in the form of bubbles. There are also many different tests to confirm the presence of a gas, and the presence of a gas can tell us whether a chemical reaction has happened or not. The third observable characteristic is a change in state. I'll be explaining this using the example of a burning candle. In the candle, the wax is solid. However, due to the flame of the candle, the wax melts and the molten wax travels up the wick, where the flame once again converts it into two new products, which is carbon dioxide and water vapor. Over the course of the reaction, we can see that there is a change in state from the reactants, which are solid and liquid, to the products, which are gases. And since there has been a change in state over the course of the reaction, we can conclude that a chemical reaction has taken place. The fourth characteristic is a change in temperature. There are many reactions in which there is an increase or a decrease in temperature. The reactions which release a lot of heat cause an increase in temperature, and the reactions which decrease heat are the ones that take in heat from the surroundings. In this example that you can see over here, water is added to quicklime, and this reaction produces slake lime. And this reaction also produces a lot of heat, causing the beaker to turn hot. However, as I mentioned before, there are also chemical reactions which cause a decrease in temperature as they take in heat from the surroundings. The last and fifth observable characteristic is the formation of a precipitate. Before we go on further, we need to understand what a precipitate is. Now, a precipitate is an insoluble solid that emerges from a liquid solution during a chemical reaction. When two soluble salts react with each other, they form an insoluble substance that is unable to dissolve, and this is known as a precipitate. Over here in this example, we can see that sodium sulfate solution and barium chloride solution have been mixed together in this beaker, and they react to form two products. One is sodium chloride, which is a soluble substance and dissolves in the solution, and two is barium sulfate, which is a white insoluble solid or precipitate which does not dissolve in the solution and instead forms at the bottom of the beaker. The formation of a precipitate is known as precipitation. The next topic we have is chemical equations. Chemical equations are nothing but the symbolic representation of a chemical reaction. We use chemical equations for ease and convenience. It is really hard for me to say that magnesium reacts with oxygen to produce magnesium oxide. Instead, it would be much easier if I use the word equation, which is this. Magnesium plus oxygen gives us magnesium oxide. Over here, the arrow you can see is kind of like the equal sign in chemistry. It tells us that these two reactants react with each other to yield this product. But even this is kind of hard when dealing with complex equations, and hence we use chemical equations, which are nothing but word equations with the help of chemical formulas. As you can see over here, instead of magnesium, I've written the chemical formula of magnesium. Instead of oxygen, I've written O2. And instead of magnesium oxide, I've found out the formula of magnesium oxide and written it, which is MgO. That is all for today, guys. Thank you so much for watching this video. I hope you liked it, and if you do, please do like, share, and comment down below. Click the link in the description for part 2 of the chapter, in which I will be teaching you how to balance chemical equations, and please do check out our website. Thank you once again, and bye.